let's look at g of x. What's the first thing you would do to g of x before you started taking derivatives? Okay, good. I would change this piece to 3x minus 2 to the 1/2 power. But then I have to ask you a question. What's in between here? And is this just a constant? No. So what do I have to do if there's multiplication in here? A product rule, right? So I'm going to do left, d right. How do I do d right? Okay, so I have a product rule, but when I do d right, I have a chain rule, right? So this is where this starts to get tricky because I have multiple rules. Now, a lot of people will ask me, and one of you will come up and ask me soon, how do I know if I do the chain rule first or the product rule first? Well, it depends on the problem. Look at what is going on, and you see a clear-cut left and a clear-cut right, and the right-hand piece happens to have a chain rule. It's not that it's just that when I take d right, it happens to be a chain rule. Does everyone kind of see what I mean by that? So we'll have to take each case one by one.
And that second part's just the derivative.
When do you use the chain?
When you have something on the inside. So the 3x minus 2 is not just an x.
That's just the derivative of.
Why do you have to times by 3?
Because that's the chain rule. So see the 3x minus 2?
Yeah. How did you know to use it?
Because there's something with it.
It's got something on the inside.
Which?
This thing over here has an inside and an outside. And so to take its derivative, I have to use a chain rule because it has an inside and an outside. Plus, right? D left, which is much easier. Everything from here on out is only multiple choice matching. The calculus is done. That is the derivative. I'm done. But I do want to show you some calculus simplification. Okay, any questions about how I got that first piece? Look at it carefully and then see if you have any questions.
Remove your head, please. Thank you.
Where did the square root on the bottom come from?
Because there's a
Negative 1/2.
Negative 1/2 moves it to the bottom. And then the 2 on the bottom came from the 1/2.
Yep.
And the 3 and the x cubed were on top.
Yep. Can you scroll it down a little bit?
Because my head's in the way.
Is that far enough?
No.
Drew, stop.
What?
Okay, again, everything I'm doing from here on has nothing to do with calculus. And the only reason, so on your homework, if it's not multiple choice, you don't have to do this stuff. But you need to know how to do it because sometimes multiple choice comes up, like on half of the AP test.
Why is it 2 to the square root of 3x minus 2?
See the 2 that was on bottom here?
Yeah.
And then the 3x minus 2 to the negative 1/2 power. Let me move it up just.
Yes, that goes to the bottom.
Right.
But why is there 2?
The 1/2.
What happened to it?
The 2 right here.
Okay, makes sense.
Is it really?
I'm going to get a common denominator. Again, no, you don't have to do this on your homework. The only reason you would do this is if all the answers only had one piece. You might have to get a common denominator. Why did I multiply by 2 square root of 3x minus 2?
Get it off.
That's the other denominator, right? The nice thing about it, what happens to a square root of 3x minus 2 and a square root of 3x minus 2?
Cross out.
They just turn into 3x minus 2. So I have 6x squared times 3x minus 2. So there is no square root. And then can I simplify the top of that a little bit more?
Yes.
Whoops. Thank you.
You already
I don't know. You gotta watch me. Sometimes I mess up.
did you say you got it?
That's okay.
It happens.
No, that's impossible.
I'm glad y'all think so.
Oh, actually, you did mess up. You're not teaching me straight.
I'm sorry.
Yeah. You kind of talked about what it's like.
I understand. You're allowed to be mad at me. Okay. I can take it.
So if you're mad at you, does it mean we're not discussing?
No. You still need to pass the AP test. So you need to learn everything you can learn from me now.
Let's do another year.
Yeah, but you need to learn everything you can learn from me now. Okay. Any questions about that one?
Oh, we need to do.
It was hard for me to tell you. Like, this was the class that I really dreaded it. Like, I felt bad. The rest of my classes didn't care because they're seniors.
Sorry. We in class.
Yeah, except that college algebra I have like 5 total underclassmen.
I understand why you did not do it.
Okay, so the chain rule, you take the derivative of the outside function. So if you look at this one, the 1/2 power is the outside function. So to do the derivative of that, you do 1/2, leave the inside alone to the negative 1/2. Then you multiply by the derivative of the inside, which is the 3.
Oh, yeah, I remember.
Okay, 2 ways. An easy way and a hard way.
Let's do the easy way.
Well, if you can come up with the easy way, sure.
Okay.
Okay, what would you do?
I would distribute.
Distribute what?
Square.
The square, so 1 squared over x plus 2 squared? Okay.
Is that the hard way?
There is an easier way.
Oh.
I think the hard way.
Okay, so we're going to do this derivative. But this is easier than one option.
Yeah.
One option is leaving it alone, right?
And doing the product.
It would be a chain rule, and what's inside of that chain rule? Quotient rule. So it's chain rule with a quotient rule inside, which would be pretty nasty, right? This way changes it to a quotient rule with a chain rule inside. I prefer this one.
Yeah, let's do that one.
Okay, now I'm actually going to do it the hardest way and the easiest way. The middle way is kind of somewhere in between. But I just want to show you there are almost always 2 ways to approach things. But the more algebra you can do on the front end, the easier the problem will be on the calculus end. So, the first way is chain rule. What is the outside function? Squared. So I do the derivative of the outside, leave the inside alone, times the derivative of the inside, right? How do I do that derivative?
I don't know the
Quotient rule, right?
-2 x minus 2 1.
No.
1.
Low D high. What is the derivative of 1?
I was go.
Yeah, we'll do that in a minute. Minus high D low over low squared.
It's a lot of work.
It is a lot of work.
-1 over x plus 2.
So you end up with -2 over x plus 2 cubed.
Yes.
-1 times the 2 is what you have on top. And then on bottom you have x plus 2 times x plus 2 squared, which would give you x plus 2 cubed. Or you could do that this way. -2 x plus 2 to the -3, which is the same thing. One way was a lot easier than the other. Is it okay if you accidentally choose the harder way?
Yes.
Yes.
Understood one at the end of the
Yeah.
That's level 1.
Yes. Good. Times 1. Chain rule.
I'm just making sure.
Yeah. All right. Any questions about that one? We're going to do some nastier, harder ones.
Sweet.
Okay. Why is this one nastier and harder than the last? It's a chain rule inside a chain rule. Does everyone see it?
Yes. Isn't there another chain rule?
Maybe. Let's start by identifying the outsidemost function. What is good? Everyone agree the square is the outsidemost function. So what's step 1? Do the derivative of the outside, leave the inside alone. You might check to see if there's any algebra you want to do. Do any of you want to raise this to a 5th power? No. Now, if that were a square, would you maybe opt for that option? Yes. So use your, judgment on when algebra is easier or when just tackling the calculus is easier. This one, nobody wants to raise raise a binomial to a 5th power, right? That would be nasty. So I'm going to do the derivative of the outside, leaving the inside alone. Well, the inside was x squared plus 3 to the 5th plus x times the derivative of the inside. Well, the inside's that blue part. So now, if you can in your brain or on your paper, ignore the red part. Like, put your hands around the red part. I now just want to take the derivative of the blue part. The first piece on the blue part, would you agree it has an outside? So, I get 5, leave the inside alone to the 4th power. The inside of that was x squared plus 3, which means I need to multiply by the derivative of that, which is 2x. Would you agree I'm finished with the first part here? Yeah. Okay, and then what's the derivative of x? Plus 1. So that was a chain rule inside a chain rule.
Why is that?
Why does it have plus 1? What's the derivative of x? There's a lot of simplification you could do there. I'm going to spare you most of it and just do the basics. Yeah, we took the derivative, didn't we? Now, if you were matching multiple choice answers, a range is necessary. Really all I did was multiply the 5 and the 2x together, pretty much. Now, I'm not saying there's not more you could do. You could FOIL that out if you wanted to, but it would, and I would rather not. So if you must match multiple choice, do it. If not, don't. And again, even when I do a nasty simplification up here, do you have to do that on your homework? Only if it's multiple choice and you're trying to match. Alright? Alright. So these are kind of the nasty problems. We're working the nasty problems right now.
When do you think this goes? Tomorrow?
No. We will start mastery Monday, and then the test will probably be a week and a half or 2 weeks after that. It's got to be before, probably around 9th or 10th is when it has to be. We have to hit the test before then. But we shouldn't have a problem.
Points if you test mastery the first time.
Absolutely. Every time.
How many bonus points?
5. Test bonus points. 55 out of 50.
Oh.
If that is something you want to aim for, you should start memorizing these rules now, like the derivative of sine and cosine and whatnot. Okay, what rule is the first rule I have to pay attention to?
The product rule.
Why the product rule? Because it's sine of 4x times cosine of 3x. So I have a left-hand function and a right-hand function. So I need to do a product rule.
Lefty, right.
Left. Did you watch that video, Miller?
No, I'm not getting onto it.
Miller, you're gonna end up really getting behind. D right. What is the derivative of cosine?
Negative sine.
Staff, please burn the eruption. I need to see the following students in high school office. Shanks Moore, Bailey
Like
Miller,
that?
Andrew Bean,
That
Martin
it?
Spalding, Jessica Wheeler,
What?
Faith Hobbs, Mariah Conkle, Cy Taylor in the high school office. Thank you.
I'm sure I can bring something out to the front.
Was that sine of x that we just took the derivative, or cosine of x that we just took the derivative of? No, it wasn't.
Yeah.
Y times 3.
It was inside.
Chain rule.
Huh.
There was an inside. If there's an inside and it's not just an x, you always have to multiply by the inside. This product rule, but the D right had a chain rule. That's not the rule for sine. Or for cosine. The derivative, we just follow the rule for cosine. If it were a power, we would. Now, on the inside, we did do a power rule. The 3x, and the derivative of that was 3. Plus, right, D left. Well, what's the derivative of sine of 4x?
Cosine 4x. Then they just mark. Thank you.
Go back up first.
Yep. Now, you don't have to. The only thing I would actually do if I were writing it down on my paper is I'd move the 3 and the 4 into the front. But use the constants at the... That's all I would do. What do I need to do when I see sine squared?
Yeah.
Rewrite it as sine of 3x squared, right?
You have to put those extra parentheses.
You don't have to, but I'd recommend it. It'll help you see chain rule. Because how many chain rules are there? There's 2 chain rules, right? There's the square, and then the 3x inside sine. So you have 2 different insides. Everyone see that? Remember, I'm going to start with the outermost function. 2, leave the inside alone to the first. And then I'm going to block out to the outside part and just talk about the derivative of sine of 3x. You just did the derivative of sine of 3x or something very similar to it, didn't you? How do you do that? Cosine of 3x times 3, because you had that extra inside. Fun, fun, fun.
So why do you time?
Okay. So the inside function was the red part. So when I do the derivative of it, the derivative of sine of 3x is cosine. Leave the inside alone.
So that's
And then the 3x is an inside. So you have to multiply by 3. Because when you do the derivative of sine of 3x,
And you have like 2 of them, you always multiply it.
you always do the derivative of the outside times the derivative of the inside. Now, I will be careful about just saying multiplying together. Like, I've seen people mess this problem up here by just multiplying this thing just by this inside here and forgetting the plus 1. So you do have to actually take the derivative of the inside. That's why I said block off what the outside was, and then take that derivative maybe separately if you need to. If you need a side note and find the derivative separately, do that. Devin, stay with me.
I'll just pause more here.
Don't pause. Ought to.
Brain.
Okay. This one is just mean and nasty. First thing I'm going to do is rewrite. Does everyone agree with that? So I have the square root on the very outside, which would be a 1/2 power.
This hurts me.
That's my job.
It hurts me? What?
Your brains, yeah. That's why you took this class, right?
No, to get hurt because my dad
To hurt your brain.
I just like math.
If you wanted something easy, there are easy math classes. You chose the wrong one. Okay, any questions about how I got the rewrite? It's got a lot going, doesn't it?
Yeah.
Okay, but what am I going to do first?
Who's the one after the front?
The outside most function, right? So I get 1/2. Leave the inside alone to the negative 1/2, correct? The inside was 2 plus x to the 1/2 to the 1/2. Chain rule. All right. Any questions about that part? Now I'm going to multiply by the derivative of the green part. What is the derivative of 2?
0.
Okay. What is the derivative of this piece? Notice it has
Another chain rule.
an outside. So I've got 1/2. Leave the inside alone to the negative 1/2. The inside was 2 plus x to the 1/2. Okay, have I done all of the outside part there, right? And then what do I need to multiply that by? The derivative of the inside, the derivative of the blue part. Well, what's the derivative of 2?
0.
And the derivative of x to the 1/2 is... Okay, done.
If I do this on a test,
You will practice on the mastery test.
Oh. I did it on the first try.
Okay, I'm going to bring your attention now to your calculus helper and teach you how to read it. If you will, look at the derivative rules. Will you turn that air down a little more? Is it still hot in here? It doesn't feel like it did anything. Turn it. Turn the yeah. Is it not cooking up?
You idiot.
Well, I thought it was already on cooler. I would have. Okay, everyone pay attention. Quiet. Okay, y'all listening? You may notice these rules look very similar to the rules we've already learned, except instead of having x's, they have u's. But it still says ddx. What this is saying is, don't forget the chain rule. Don't forget the chain rule. Don't forget the chain rule. Because look, if we take the derivative of natural log of u, remember you did natural log of x, right?
Yeah.
What was the derivative of natural log of x? 1 over x. But if x is anything besides x, what do you have to do? Multiply by the derivative of the inside, right? See, this is 1 over u. Don't forget the chain rule. See how that's what this says?
No.
Because the u prime is the derivative of the inside. Well, u prime is the chain. So, yes.
Why is it
For now, you must memorize 1 through 14, 21, and 22 for now. 1 through 14, 21, and 22. What is 21 and 22? Product rule, quotient rule. And 1 through 14, look at them. Have you seen them all before? That's okay.
Mine's the personality, that one.
Yeah. So say you have e to the 2x. Right? What is the derivative of that? Well, you learned from the other day when I just said, hey, it is. It's just e to the x, right?
Yes.
But it's not x, it's 2x.
So it's going to be e to the 2x.
Times y times 2.
How is there inside out?
Well, 2x is not an x, right? That's the inside. E with the 2x is on the inside, right? Think about when you did transformations. The inside of the function would have been the power on that one. So, you see how 2x would be the inside? So you would have to multiply by 2? Okay, that's what this says. The derivative of e to the u is e to the u times whatever u prime is, the derivative of the inside. See it? All this says is follow the rules you've already been following, but don't forget the chain rule.
Is that all between
On their actual test, there will be questions. The mastery exam will be memorization and then do these derivatives. Okay, some AP practice. Okay, quieter. The derivative of f of x is g of x, it says. If h of x is x squared, what is the derivative of f of h of x? How do you do it? The derivative of the outside. What is the outside function over here? F. And what is the derivative of f? So g, except I leave the inside alone. What was on the inside?
H of x.
Okay, so that's the derivative of the outside. Times h prime of x. Everyone agree? Well, what is h? So x squared, what's the derivative of x squared? So D is the correct answer on that one. Okay, one more example. Have you seen something like this before? The U's and V's on your homework that we still need to grade? Yes. Do what? Okay. All right. Left D right, right D left. Everyone agree?
Yeah.
So h prime of x would be left D right plus right D left. Everyone agree with that? And plug in 2. What's f of 2? I hope it's in the table. F of 2 is 3. G prime of 2 is -3. Well, this says find h prime of 2. G of 2 is 4. F prime of 2 is 5. Multiply 9 and 20, 11. I'm going to skip the quotient rule. Could we do quotient rule? Low-D high, high-D low, low squared. I'm going to do the new one, which is chain rule. H prime of x would be f prime of g of x, right? Times g prime of x. Agreed? I would need to find g of 3 first. G of 3 is 2. And then I would need g prime of 3, and I would find both of those. your homework is a worksheet in the